Okay, I think I'm gonna go ahead and start now. Whoever else joins is gonna be late. By the way, I have construction going on, so if you hear something or if you don't get me the first time, you can ask me to repeat it. But I'm gonna go ahead and screen share. Um, Let me know when you can see my screen. Um, all right, can you guys see this? Okay, yeah. All right, so welcome to our Advanced Python workshop presented by WorthyWorks Foundation Corp. So just to preface before we actually start, since this is an advanced course, we'd like you to at least have a little bit of base knowledge about Python, essentially the fundamentals, how things work. So, for loops, while loops, print statements, all that easy stuff. Basically having that for our course is going to make things a lot easier since this is a little bit more advanced. But if you don't have it, it's okay. We'll walk you through the steps. Um, what we're going to be covering over the next 2 days are functions, generators, data serialization, concurrent programming, and meta classes. So functions, generators, and data serialization we'll be covering today, and the other two we'll be covering tomorrow. Okay, so before we start, I'm just gonna explain who we are and our mission. So we are WorthyWorks, a nonprofit organization dedicated to providing STEM and other educational courses and activities with a particular focus on coding and technology-related subjects. Our mission is to empower children by sharing our knowledge and demonstrating that learning can be enjoyable and exciting. In case you guys don't know me, I am Arnav Tripathi. I'm a rising sophomore at JP Stevens High School.
I'm Devon Shah. I'm also a rising sophomore at JP.
Okay. So I'm sure a lot of you will be going to JP for your high school since you are in the area. So you'll see us around. Okay. We're first going to be starting off with functions. A lot of you might know how functions work, but we're just gonna demonstrate these. So the editor we're going to be using for this course is we're going to be using an online Python editor. I didn't want to go through the steps of installing an actual IDE when everything could be done on. So I'll paste the link to the online one in the chat and you guys can use that. If you have your own already and you're comfortable with using that, then you can use that. Oh, it looks like somebody else joined. Okay. Okay. All right, Ishan, I see you just joined. We didn't really start yet. I just did the intro. Um, I'm not sure if you got the link in the chat. I'll paste it again. We're basically just using this online Python editor and we're gonna code using this. Let me go. Okay. Can you guys see my screen on the editor or is it still on the slides? All right. I'm just gonna reshare for a second because okay. All right. So as I was saying, we're gonna be starting with functions. And functions are basically just blocks of reusable code that you call throughout your program. So if you're coding something really large and you have a specific piece of code that performs a task that you want to repeat throughout the program, you can create a function and then you can use that block of code throughout your program multiple times and just call it whenever you want that to be executed. So essentially just related groups of code. And then we'll be creating a Fibonacci sequence using functions. And we're going to be printing that up to a specified number of terms. In case you guys don't know, Fibonacci sequence is just a series of numbers where each number is the sum of the two preceding. So we start with 0 and 1. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 3 is 5, and so on. So we're going to be creating a Fibonacci sequence using functions. We'll also be covering aspects such as parameters, calling the function, etc. Okay. So to start, can I just like get like a thumbs up or something in the chat to know that you guys all have this open? All right, Ishan, your phone. All right, Satvik, are you good? Okay. All right, nice. Okay, I'm gonna go ahead and start now. So what we're gonna be doing is first defining the function we're creating. So I'm just gonna call it fib generator. So first we define our function fib generator. And basically, by defining it, we also have to assign it a parameter. So, and this parameter is going to be called n. So n basically in this case, it stands for it's a numerical value representing the number of terms that we want to generate in our sequence. Parameters usually they represent any measurable value. In this case, it's just the amount of terms we want to generate in our sequence. Next, we're going to create an empty list because we need a place to store our sequence. So I'm just going to call it sequence, and then it's equal to, and then open, and then open and close bracket. And this is going to be our empty list, which stores our list. And just forgot to put a colon here. Make sure there's a colon there. Next, we have to define two variables. So, and these are going to represent our first two numbers. So I'm going to call them A and B, just as, first letter of the alphabet. And we're going to set them equal to 0 and 1. I'm not sure why I did that. Yeah, Nifon.
So when we're doing like, let's say in line 3, do we put an equal sign or a dash?
For line 3 is an equal sign.
Okay.
Yeah. Looks like someone just entered the waiting room. Okay, Hari, do you need the link to our okay. Hold on, guys. I think one more person is joined. Okay. I'm just gonna share the link to the editor again in the chat, just in case you don't have it. All right. Okay. So right now we've just defined our function. We've created our empty list, and then we have our two variables, A and B, which represent 0 and 1. These are our two starting numbers. Once we've done that, we're gonna create a for loop. And we create this for loop because we want to iterate through the program for a certain number of times. That's going to be defined by n, the amount of times we want it to go through. But we need a for loop to be able to do that. And just in case you don't know or don't remember, a for loop is just used to iterate through a certain amount of code for a specified number of times. So what we're going to do is we're going to say for, and then underscore in range. And then we put in n. So remember what we defined up here. So for underscore in range n, colon. And remember n is the amount of numbers we want to generate in the sequence. We're going to say sequence. See some. Sequence dot append, and then a. Devansh, if you mind answering the chat questions,
Alright, I got it.
you could do that while I continue. So sequence dot append a. All right, and then we're going to do a comma b. Right, so these are our first two terms, 0 and 1, and we're going to set these equal to b. We're going to set this equal to b. So basically what's happening here is it's the first part of the fib sequence. So it's 0 plus 1, that will give us 1. And essentially what we're doing here is we're adding the first two terms, and then we're setting that equal to the second term. So how this fib generator works is that by continuously swapping a and b, by swapping the values of those, the sum of a and b then becomes the previous term, and then we can add on more. So then we're going to say a comma b is equal to b, and then comma, and then a plus b. All right, so this is basically adding our two values, and then this is setting both of them equal to b. Okay. Let me just make sure everything's correct, and comma b is equal to b, and then a plus b. Yeah. And now all we have to do is return our sequence. So return. This should just be tabbed. Everyone can tab this. It's because I forgot to put the colon before. And then your return should be right here. Okay. And then return sequence. Does everyone have this so far? I just want to make sure. You can do like the thumbs up. If you don't, that's fine. We can wait and give you more time. Okay, so just to go over what we've done so far is we've defined our function. We've created our empty list. Now this is where all of our data is stored. We've created a and b. These are our two variables representing 0 and 1, our two starting terms. And then we've created a for loop, which goes through a certain number of times, and it adds a and b, and then it swaps them so that a becomes the previous term, and then b becomes the sum of the two previous terms. Okay, so that's how the for loop works, and then we're just returning the sequence, so we call. Now we just have to, so we're basically done with our function over here. Now we just have to call it in our program. So we have to do num underscore terms, and then we'll put it equal to 10. Or you could do whatever, you could do 8, 5. And this is the amount of times we're gonna have it run. We actually haven't associated this yet with our n over here. That's what our next line of code is gonna do. So we're gonna do fib sequence. And we're gonna set this equal to our function over here, fib generator. So you can just copy and paste this. But then inside, for the parameter, you're gonna do num terms. So basically what we've done here is we've associated this value that num terms has with our parameter n. So then we know how many times we want the sequence to iterate. So now that we've called that, we can just print our statement. So we'll do print, and then the fib sequence up to, and then in bracket, curly brackets, num terms. So then it's going to say, it's just going to print the number that you have over here up to num terms. Terms is, and then colon, and then we just put our fib sequence over here. And then close your quotation mark. Okay, just making sure everything's good. Oh, make sure your fib sequence is in curly brackets. All right. Now if we run this program, we should get our Fibonacci sequence generated. So basically it's doing 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, and then so on. So that's how we get our Fibonacci sequence. So this is our function part of it, and then this is calling the function. And then this is also defining what n is over here. So we've associated this num terms equals 10 with the parameter n that's assigned to this function. Does anyone have any questions? Does anyone need more time? Yeah, Nifon.
When I tried to run it, it says in line 7, there was like an unexpected indent.
Did you indent the 4?
Yeah, I have it the same way that you have it.
You can share your screen and then I could fix it from there. Hold on.
Okay.
Let me just update the screen sharing permissions. All right. You should be able to now. Is equal to, let me just verify with my code. Hold on. AB01 is not indent. Yeah, that's the issue. Thanks, Madhav. So basically in line 5, you just have to tab it there.
Oh.
Yeah.
Okay.
And then it says line 14. Oh, so just don't indent the fib sequence and then the print at the end.
Like that?
And then you can try running it again. Yeah.
Okay.
All right. Does anyone else have any questions, comments? If not, we can. I'll just show you guys how to save it. Because I don't want you losing this. So you can just click this save to disk over here, or you can click F9, whatever works for you. So just click this and then you can name your file, whatever. I'll just keep it FibGen, save that, and then you can save it wherever you want in your computer. Once everyone is done, just give me a thumbs up and then Devansh will take the next topic. I'll give you guys until like 126-ish and then. I. Okay, if you guys are good, I'm gonna hand it over to Devansh now.
Okay, I'm just gonna share my screen. Okay, so we just went over functions, and now we're gonna move on to generators. 1 second. Okay. So, I'll just go over what the main idea of what we're gonna create. So generators. So in Python, a generator is a special function which is yielding values one at a time, allowing efficient iteration over a sequence. So, yielding, this is an important keyword that you want to keep in mind. We're gonna use it in our code in just a bit. I'll go over about what that actually does after we start coding. So it provides a memory efficient way to generate and retrieve values on demand, making it useful for large and infinite sequences. So you want to just keep in mind that the main point of the generators is basically it's able to produce the data without having it stored in a previous memory, which makes it a lot more efficient and just a lot more quicker. So instead of us creating um like a memory to and we plug in the values that we want, it's just able to produce it on its own. So it's a lot faster. We don't have to recall it or anything. So and the example we're gonna create, it's a Python generator that generates the squares of numbers to a given limit, and we have to define that limit. And it's gonna produce squares on demand one at a time without the need to store them in any memory, which is why it's more efficient. So I'm gonna start coding it. So you can open up, you can have like a blank, what do you call it? Your surface, you can just clear everything. So first what we're gonna do is define a function. So we're just gonna do diff, which is for define, generate squares, and in parentheses have limit, and then a colon. So this function, we're gonna actually basically copy this and use it somewhere else, which is gonna define the exact limit that we're using, that we want the squares to generate up to. And by squares, just so everyone knows, it's like the square of 2 is 4, 3, it's 9, like multiplying it twice. So 2 times 2, 4, 3 times 3, 9. So we want that to be generated without storing it previously. So this is defined with a single parameter, which is limit, which is going to be basically the borderline that we don't want to surpass a certain limit. So we're going to generate the squares numbers to a specified limit, and the parameters is going to be our borderline. And yield, as we were talking about before, what yield is mostly used for, instead of return, which is another function, yield allows the function to return a value and resume from where it left off. So if we didn't use yield, what would basically happen is, let's say it would be the square of 2, which is 4. Then it would square 4, which is 16. And then it would square 16, and so on. We want it to go from 1 to 2 to 3 to 4, which is what yield is doing. It's going to square 2, which is 4, but it'll forget about that. It'll come back to 3. It'll go back to where it left off, which is the main point that we want to cover. So what we're going to do now is have a for loop. So for I in range, and in parentheses have the limit. So for every integer in the range, we want it to yield the number or integer, and the symbol 2 asterisks after a space, this is basically in Python saying we want to square the number, and 2. So 2, like to the power of 2, that's what it's for.
Wait, just to interrupt for a second, the meeting, since we're using free Zoom, it ends in 40 minutes, so if the meeting ends, just rejoin with the same one.
Okay. So where we left off, so yield every integer and square it. So we're gonna yield to 2, square it, which is 4, but then we're gonna come back to 3 instead of squaring 4 and so on. Okay, now we're gonna create a variable. So squares underscore gen equals, and as I said before, we're gonna basically copy paste this over here, this function, and the limit, and now we're going to define the limit. So what number do we want to square it up to? So we don't want this list to go infinitely. We want it to stop at some point. So you can put in any number. I'm just going to put in 5 right now. Okay, so we're going to generate squares up till the 5th number. Okay, and now we just have to call upon. So for square in the squares generator. So oops, squares underscore gen. We wanted to print out the square, every single square that's been generated. So square. So this is it. So what we just did here, we made a variable, and we told it that the limit that it should generate the squares is up till 5. So stop after 5 numbers have been printed out. And we used a for loop to continue this process, continue spitting out the numbers until the 5th number. And we have another variable here, square. So every square in the squares generator, we wanted to print that out. So if we run it, see, line 8. Is not, I might have, oh yeah, okay, so
I think squares is spelled wrong.
yeah, I did. Thank you. Yeah, I spelled it wrong. Okay, so now it should work. Yeah. So so we have 0, 1, 4, 9. So 1 then is going to 2, which is printing out 4, then 3, 9, and then 4, 16. So once we square all of that, instead, if we didn't have the yield, then it would basically go from 4 to 16 and then so on. Yeah, so this is generating the generators function in Python. If you have any questions, then you can ask now. Like if anything you don't understand. And if not, just give like a thumbs up.
For me, it says squares is not defined.
Um,
So do I have
is
to
it
like,
the same error I had because I misspelled this?
oh no, they're spelled correctly.
Okay, share screen and we'll figure it
Yeah,
out.
okay. Oh, give me a sec.
Okay.
Here, right here. So it says squares not defined.
Yeah, so look at line 8. It
Uh-huh.
says 4 squares, so it's plural there. So delete the S.
Oh,
Yeah, I had the same thing except for the other variable. Yeah,
okay. Yeah.
okay.
For me, it's just showing one. Like, for like the 5 results, it just shows one.
Uh, remember when we defined a limit? I put 5. Did you put a different number?
No, I put 5.
Okay, share screen. Oh, let's see. Oh, so the reason why it did this is look at line 3. We defined I as that variable, and in line 4, instead of I, you put 1. So it's just repeating 1 to the power of 2 5 times.
Right.
So yeah, run it now and it should work.
Thank you.
Yep. Okay, anyone else? Just put a thumbs up so we know everything's working, and then we can move on to the next topic. Okay. Okay, so the next one we're talking about is data serialization. So data serialization is the process of converting complex data structures and objects into a easy facilitated format, storage, transmitting over the web, and sharing. So any like complex data structures, they're basically simplified, and it's in a portable format where it's able to be easily shared and transmit over the web. And this serialization enables data to be represented in a string of bytes, textual format. And this is the reason for that is so that it can be easily deserialized back into its original form for if you have any other utilization of it. So in this next example that we're going to be coding, we're going to use JSON, which is JavaScript Object Notation Format. And this is basically the Python way of using data to be interchanged, and so it's human readable and easy to handle. So I'll code, since this is the last one, I'll code the first half, and then Arnav will do the next one. Okay, so first, as I said, JSON, we're going to import JSON. So this is the module, and we have to actually import it into our program so that Python knows we're now using something based on JSON. So this is going to provide the basic functions of JSON that we're going to be working with. And all we're going to do is create a data profile for someone, and then like sort of transmit it over the web. So we're gonna make a variable called data and set that equal to, and we're gonna put in whatever we want, right? So have curly brackets and space it out a little bit. Inside this, we're gonna put some simple attributes, right? So name of the person. You can put any name you want. And then the age of the person, a colon. And for this one, don't use quotation marks because it's an integer. So any age and the city. So you can just put any city you want. I'll just put New York. And remember, these are all strings, so we want to put them in quotation marks and numbers, integers. Also, I forgot one thing. You want to put commas after each of these. So just the first two because this is the ending, and it's all going to be put into one line. So we want commas to decipher that.